Hi everybody, this is Ryan, and I'm here for a video for Newman University for Math for Liberal Arts to talk about the first module. So let's get started. So this is our Canvas homepage. From here we're going to go to modules. In the introductory video, I talked you through the start here. Today we're going to go through and we're going to take a look at week 1, whole number and integers. And I'm going to go right down here to Instructor Week 1 Video and Presentation. So let's click on that. And I want to make a quick video on your first concept, so your first topic. So your first topic is whole numbers and integers. So let's get started with that. So let's first talk about whole numbers. Whole numbers and counting numbers. Counting numbers start with 1 and continue, and whole numbers are the counting numbers that include 0. So a good way to remember this, counting numbers are things you can count, like there's 1 car, there's 2 cars, 3 cars, 4 cars. And whole numbers are all the counting numbers, including 0. So let's try this. Let's look at the first one. So if we have 5 activities planned and want to number them, would we use counting numbers or whole numbers? So since there's actually 5 activities, you're going to want to use counting numbers because you're going to start at activity 1, 2, 3, 4, or 5. Number 2 says we have a seating arrangement where seats are numbered from starting at 0. Since the seating arrangements include 0, you're going to want to use the whole numbers. Let's talk about place value. So our number system is called a place value system because the value of a digit depends on its position or place in the number. Each place is worth 10 times the value of the place to its right. The place values are separated by periods, and periods are 1, thousands, millions, billions, trillions, and so on. In a written number, the commas separate the periods. So let's talk about rounding. Rounding is a method used to shorten or simplify numbers by adjusting them to the closest specific value. To round a whole number to a specific place value, locate the given place value. All the digits to the left of that value do not change. Underline the digit to the right of the given place value. Determine if the digit is greater than or equal to 5. If yes, add 1 to the given place value. If no, do not change the value. Replace all digits to the right of the given value with 0. So here's a scenario. You and your friend are planning a movie night. Each ticket costs $13.75. You want to estimate the cost for 6 people. If we round the cost of one ticket to the nearest whole number, what would it be? So $13.75. The nearest whole number would be, starting with your ones. So is 7 more than 5? It is, yes. So you're going to round that up to 14. So $13.75 to the nearest whole number would be 14. Using the rounded up number, estimate the cost for 6 people. So you would take the 14 and multiply by 6. So let's talk about adding whole numbers. The operation of addition combines numbers to get a sum. Numbers being added in an addition operation are called add-ins. A math expression that includes numbers and operations is called an expression. To add whole numbers, write the numbers so the place values line up vertically. Add the digits in each place value. Work from right to left, starting with a ones place. If the sum in a place value is more than 9, carry to the next value. Continuing adding each place value from right to left, adding each place value and carrying it as needed. Here's some properties. So these are important properties. So the identity property of addition, the sum of any number and 0 is the number. So that would be like 5 plus 0 is 5. Adding a 0 doesn't change the value. The commutative property of addition, changing the order of the add-ins does not change their sum. So that would be like 4 plus 6 is the same as 6 plus 4. In both cases, they're 10. Let's talk about subtraction. The difference is the result of subtraction. Adding and subtraction are inverse operations. One undoes the other. Subtraction can be checked by addition. Here's your process to subtract whole numbers. Write the numbers so that each place value lines up vertically. Subtract the digits in each place value. Work from right to left, starting with the ones place. If the digit on top is less than the digit below, borrow as needed. Continue subtracting each place value from right to left. Borrow if needed. Check by adding. So the food drive initially has 50 bags of rice and received a donation of 30 bags more. How many bags of rice are there now? So since they started with 50 and they got 30 more, that's 50 plus 30 or 80 bags. Later, 25 bags were distributed to families. How many bags are left? So if you have 80 and you subtract 25, so 80 minus 25 would be 55 bags. Let's talk about multiplication. Multiplication is a way of representing repeated addition. We call each number multiplied a factor and the resulting product. When we multiply by a number with 2 or more digits, we multiply by each digit separately, working from left to right. Each separate product of the digits is called a partial product. Here's a couple properties of multiplication. Multiplication property of 0, the product of any number and 0 is 0. So it'll be like 4 times 0 is 0. The identity property of multiplication, the product of any number and 1 is the number. So 4 times 1 is 4. The commutative property of multiplication, changing the order of the factors does not change the product. So like with addition, 4 plus 6 is 10, and 6 plus 4 is 10. 4 times 6 is 24, and 6 times 4 is also 24. The order doesn't matter. Talk about division a little bit. Division is a way to represent repeated subtraction. So multiplication represents repeated addition. Division represents repeated subtraction. We call the number being divided the dividend, and the number dividing it the divisor. The result of dividing is called the quotient. The number that's left over from the division operation is the remainder. Here's a couple of properties for division. The division property of 1. Dividing any number except 0 by itself produces a quotient of 1. So it's like 10 divided by 10 is 1. Division property of 0. Any number divided by 0 is undefined, while 0 divided by a number is always 0. So you have to remember there that like 10 divided by 0 is undefined, but 0 divided by 10 is 0. The way that looks is like this. So you have 10 divided by 0. That is undefined. And we usually write it like this. U, N, D, undefined. Whereas 0 divided by 10 is 0. Okay, So you need to keep that straight. That's important. Particularly when we get into graphing lines and slope, that will make a big difference. Let's talk about integers. Opposites and integers. The opposite of a number is the number that is the same distance from 0 on the number line, but on the opposite side of 0. Integers are counting numbers and their opposites, and 0. So here are the integers. So they mention a number line. So here's a number line. Here, and we usually put arrows on the end of it to make sure we understand that it goes on forever. Here's 0. So if we have a counting number or whole number of 2, notice 2 is 2 digits from 0, because 2 minus 0 is 2. But we go also over here to the opposite, and the opposite of 2 is negative 2, and negative 2 is also 2 units from 0. In both these cases, the distance here is 2. So keep that in mind. So integers are the counting numbers, 0, and their opposites. And opposites are the same distance from 0. We can compare and order positive and negative numbers using inequality symbols like less than or greater than. On the number line, going from left to right, numbers increase in value. Going from right to left, they decrease. So as you go further to the left, numbers get smaller. And as they go further to the right, the numbers get bigger. So remember back just a minute ago, we talked about opposites. Like we used 2 and negative 2, and those numbers being the same distance from 0. So think about that, and the absolute value of a number is this distance from 0. So a little bit ago, we talked about a number line where we had negative 2 and we had 2, and both those numbers are 2 from 0. So that would mean the absolute value of 2 is 2. The distance from 2 to 0, and the distance from negative 2 to 0 is 2. So the absolute value of 2 is 2, and the absolute value of negative 2 is also 2. So the way that looks is like this. Absolute value is written like this. So the absolute value of negative 2, like that, equals 2. Because negative 2 is 2 units from 0. And also, the absolute value of 2 is also 2, because 2 is also 2 units from 0. So keep that in mind. That's sometimes tricky, but the absolute value of opposites is the same. And the absolute value is always positive because it's a distance. You drive a positive distance. So adding and subtracting integers. Here's some rules. When both addends are positive, the sum is positive. When both addends are negative, the sum is negative. So that looks like this. So that'd be like 2 plus 3. That'll be 5. Both of them are positive. So the addend is positive. That would be like you had 2 apples, you got 3 apples, then you have 5 apples. If I have negative 2 plus negative 3, that's going to be what? That'll be like I borrowed $2, which borrowing is negative, and I borrowed $3 more, so in total I have borrowed $5. So that's why that ends up like that. Now, when the addends have different signs, there are more negatives, and there are more negatives, the sum is negative. When the addends are different signs and they're more positive, the sum is positive. So that'd be like this. It'd be like 10. So I had 10 apples. And I'm going to add in the 7 that I gave away to somebody, which is going to leave me with 3